All right, boys and girls, welcome back to the drive-through. Here's a little help with two things on this problem, okay? What allows a function to be differentiable? Well, it's differentiable everywhere where it's continuous and the limit exists, okay? So notice we've got asymptotes in here, and asymptotes break up the continuity. Now, if the limit existed at that point, it actually would still be differentiable. But since the limit does not exist at the limit does not exist. Why doesn't the limit exist? Because as you approach -3 from the left, you go to infinity. But as you approach -3 from the right, you go to negative infinity. And if those two points, if those two paths don't take you to the same output, then the limit does not exist. So these are the places where the limit doesn't exist, and that means those are the places where the function is not differentiable. Now, how do I say x can be anything but -3 and 3? Well, x can also not be infinity because we never get there. So x is going to be able to go from negative infinity to -3. Okay, and then it can't be -3, so we use a soft bracket. If we would have used this, well, that would have been wrong because then you're saying 3 works. Okay, well, I don't have an undo on this, do I? No big deal. Oh no, eraser. So basically, we're going to use the soft brackets, these rounded brackets, and union signs to indicate all the values that it can't be. So it's basically saying x can be anything you want in between negative infinity and -3, but it can't be -3. It still can't be -3, but it can be anything you want between -3 and 3. It still can't be 3, but it can be anything you want from 3 into infinity. So you're essentially saying this. So the key to calculus is like understanding that you've already learned a lot of this, but the notation is changing. In algebra 2, we wrote it this way. In calculus, we're writing it this way. There is a reason, and I'm not going to explain it to you. Just hope that you trust it and trust yourself. Hope it helps.